Hey guys, I am Gautam from IIT Kharagpur and welcome to GMX. In this video, I am going to discuss about the NET 2018 December question papers, and I will solve booklet B question number 31 to 40 in this video of part B. Okay, so I am solving booklet B. Okay, but all questions are same in NET exam. So the first question, that is question number 31, which was PF5, SBF5, PH3 and SBH3. This kind of four different molecules are given, and you have to find the strongest acid and the strongest base. Okay, so for this you have to just first find the strongest acid. So PF5, then SBF5, then PH3 and then SBH3. Okay, so here phosphorus and Sb, that is antimony, these two elements central atom are given. Okay, so and also fluorine and hydrogen, these two kinds of ligands, you may say, or the other atoms, okay, connected with the phosphorus or antimony atom. Okay, now let's discuss about the electronegativity order. So electronegativity order between phosphorus and antimony, which are phosphorus has higher electronegativity than antimony, and also from fluorine and hydrogen, fluorine has higher electronegativity than hydrogen. Okay, so that is why phosphorus easily attracts the electron, and also fluorine easily attracts the electron than hydrogen, and phosphorus than antimony. Okay, so that is why what we get, the system that contains SBF5, because Sb has lower electronegativity, that is why Sb will not attract that much more as phosphorus. Okay, so Sb, which has the lower electronegativity, and also fluorine, which has the higher electronegativity. If this kind of bond forms, SVF single bond, then fluorine easily attract the electron, as Sb cannot attract the electron because of its low electronegativity than phosphorus. But in case of phosphorus F, okay, I am not considering the compounds which have hydrogen, because hydrogen has lower electronegativity. Okay, so that's why just explain these, first explain these, then you can easily understand what I am trying to say. Okay, just then if phosphorus attracts more and also fluorine attracts more, then these two easily may be compromised. Okay, so that's why if here fluorine has much more electronegativity than its antimony. Okay, so that is why, of course, this system, that is SBF5 system, this one will show higher acidic character. Okay, higher acidic character means it will be the strongest acid. Why? Because if suppose SBF5 looks like this, and then what we get, if every fluorine atom attracts the electrons from antimony, then antimony will feel some kind of vacancy, electron vacancy, and that is why antimony will accept electron pair from outside. Okay, because, and that's why it will act as a Lewis acid. Okay, and here it is the most strongest Lewis acid, because it shows the highest lack of electron, and that is why highest tendency to be a acid. Okay, so now, so the final answer will be SBF5. It will be the strongest acid, and also for you can easily apply the opposite thing, and finally you will get the highest basic character, that is strongest base will be this one, PH3. Okay, in case of course PF5, or of course PF5 it will show acidity but less than the SBF5, but in case of SBH3 and PH3, for the opposite reason, whatever you can apply for acidity, you have to apply the reasons behind for the basicity. Okay, so for the opposite reasons, it will show the highest basicity, and that is why option 2, that is SBF5 and PH3, is the correct option. Okay, so now coming to question number 32. So that says, among the SI, this kind of four systems, you can see the question on your screen, the zero dipole moment. So of course you know SiCl4, this is like CCl4 or CH4 methane. So it's a steady structure, it has mu equals to 0, that is no dipole moment. And also POCl3, which looks like this one, so it has of course dipole moment, that is mu not equal to 0. For NF3 looks like this. If you apply VVT, then you will get the structure. Okay, and this is also some kind of dipole moment, so mu not is equal to 0. And finally trans SiCl4 PY voltage, that means the SN Cl, this is the plane, and above below pyridine group. Okay, pyridine ligand, and it has also It's a totally symmetric molecule and sigma plane can passes through from anywhere. Okay, so that's why it has also no dipole moment, that is mu equals to 0. So final answer will be option 3. Okay, so now coming to the next question, that is the standard reaction potential in acid medium for fluorine, chlorine, sodium, zinc are in those order. Okay, so the order will be, okay, let's discuss this one, but first let me clear the board. Okay, the 33rd question, the question says that of course you have to find the reduction high which has the highest reduction potential: fluorine, then chlorine, zinc and sodium. The system which have the highest reduction potential, that means actually the system will reduce easily. So the system which will reduce easily, which can be reduced easily, that will have the higher reduction potential than the others. Okay, so here can be the system which can be reduced, that means what? The system which will easily accept electron. So here fluorine is the highest electronegative atom. Here we are considering F2 molecule, but just consider the atom. Fluorine is the highest electronegative atom, so that is why it easily attracts electron. And then coming to chlorine, so that's why as it accepts electron, so fluorine can form F minus, chlorine can form Cl minus. But you never have seen that zinc can form any anion or sodium can form any ion, because Zn form 2 plus and sodium form Na plus, because it easily, it's this stored electron positive system, because those are like metal. Okay, it's not a metal, but zinc is a metal. So that is why these two is cannot accept electron in that much. Of course, in this system, not the ionic system. Okay, so that's why that corresponds to fluorine has the highest tendency to be reduced. Okay, then fluorine, then coming to zinc and sodium. So zinc has the higher reduction potential than sodium, because zinc easily reduced. Final option thus will be option 2. Okay, so now coming to next question, that is question number 34. That says, among the following, the compound that will have the highest rate of nucleophilic substitution. Okay, actually you have to know the answer, because it's not, I'm not quite sure about this answer, but my solution will say that option 4 may be correct, but maybe option 2 also. So if you know, if you are sure about this one, then just let me know in the comment box or on my Facebook group. You will get the link of my Facebook group in the description. Okay, so just check and you can give in the correct answer. Okay, but I am just considering answer. Okay, so just be sure and just let me know. So now next coming to question number 35, and I am not that one that if I don't know something, I will tell you the wrong answer, because I am a YouTuber, so I should know everything, but not that much. I am not. If I don't know that, then I will not tell you the wrong things. Okay, so next coming to question number 35, that says the major product formed in the following reaction. That is, the reaction is benzene ring, then its OH, and then NH. So you already know that oxygen has higher electronegativity than nitrogen. So if electron pairs are on oxygen and also on nitrogen, then as oxygen has the higher electronegativity than nitrogen, then it easily attracts the electron and it will not donate the electrons, okay, effectively. But nitrogen has the ability to donate the electron better than oxygen, because it has lower electronegativity than oxygen. I am just comparing oxygen and nitrogen. Okay, as both are electronegative, but nitrogen has much more capability than oxygen to donate the electron. Okay, so that's why its lone pair easily attack the anhydride system, and finally we will get the product that looks like what? The product will be like this. It will not participate in the reaction. Okay, so the option will be this one. Okay, so just be careful about the answer. Okay, so next coming to another question, that is question number 36. So just let me clear the board again. Question 36 says that the mechanism for the acid catalyzed hydrolysis of benzonitrile involves. So benzonitrile is actually these ones, cyanobenzene, or you may write PAC triple bond N. Okay, so I am just showing the mechanism, slide mechanism. So if it is acid catalyzed, then there will be H plus source. So first nitrogen will attack this one, and then we will get this kind of system. This will be plus and also a hydrogen. Okay, so now then in the second step, the system that is acts as it is hydrolysis. So OH will attack right on carbon and this positive charge will be neutralized, and finally we will get this kind of structure. Okay, I am not drawing the other structures, but I can explain you the answer from this two step. Okay, finally another is to will attack, and finally we will get a different kind of product, but then I can give you the answer, I can explain the answer from this two step. Okay, so you can see the option 2 which says this kind of mechanism. Okay, so that's why option 2 is the correct. Okay, so if you want to know the about the mechanism more, then you can check the description. I will give you the link of that website or that PDF file. Okay, so just go to the description and you will get the link. So next coming to question number 37, that says the energy profile diagram for a species. Okay, it's you can easily understand it's a Friedel-Crafts acylation reaction. So this one, which will be benzene ring, of course, CH3 COCl and anhydrous AlCl3, and finally what we get, we will get this kind of structure. So it's a two-step reaction. In the first step, what we get, this benzene ring, I am showing you the mechanism. From these two we will get, I am not elaborating all these because you know already the Friedel-Crafts acylation. We will get this kind of system, cation, and this kind of mechanism we can draw. So what we get, sorry, there will not be all 5 bonds, there will have positive charge right here and one hydrogen and another COCH3. So this will be resonance stabilized, and we will get 2 more structure. Okay, for this one. So this is step 1, and for step 2 this system will be, this positive charge will be neutralized by this deprotonation or this deprotonation. Okay, so we just need to know about this, and here as it is stabilized we will consider it as a intermediate. That's why intermediate can be shown by a stable one than the transition state. So this, during formation of this intermediate, first transition state we will get, then that's why 1 will be the transition state in the graph you can see, and 2 will be this one, 3 will be the transition state of the step 2, and 4 will be the final product, that will be right, this 4. Okay, so 2 will be this one, that is the intermediate. Okay, so option 2, that is of course 2 is correct. Okay, now coming to question number 38, that says, you can see the question. Okay, so here there is a trick to answer this type of questions. So what are the tricks, or what is the trick? The trick is, this will be a Aldar-in reaction, because without this one you cannot form this kind of product. Okay, as you can see. So just this, actually I have done this question on net because I knew that option 2, 3 and 4 will not be, because work-done marine rearrangement I have already make a video on this, so that will not be correct. Then sigma-tropic rearrangement, it is not a sigma-tropic rearrangement because MgClO4 twice, it will not react like that one. Of course the reagent is not known to me, Michael addition I have no, but that reagent will not help you to give to allow to participate in Michael addition. So finally I have decided to go to option 1, and of course that is true. So I will elaborate in this video what is Aldar-in reaction. So it's quite simple. Just let me draw the structure in a different type. Okay, so if I break this methyl as like this, another methyl. Okay, this is the 5-member ring, this is the reactant, and Aldar-in reaction in presence of MgClO4 twice, this is this kind of reaction. Sorry, the mechanism will be opposite side. This kind of here, then it will accept the hydrogen, then this kind of deprotonation. So what we get finally? Sorry, this will be 5-member ring, and this one will be CO2, and this will be double bond and amine group. Okay, and this is the final product. So it is Aldar-in reaction. So you should know this reaction because it's an important reaction. You knew about Michael addition, sigma-tropic rearrangement, and work-done marine rearrangement. You have listened, but Aldar-in reaction, it's also important. Okay, so next coming to question number 39. Let's say the higher respect of stretching frequency of carbonyl group of the following groups. Okay, So three different kind of system. This one denoted by A, this one denoted by B, this one denoted by C. So carbonyl stretching frequency, that means how easily carbonyl groups can be the C double bond O, this double bond or this bond can be broken. Okay, so if this double bond character decreases, you know about triple bond has the strongest bond you have known, then double bond, then comes single bond. So here if this double bond behaves like single bond or in between double bond and single bond, okay, because if I am telling you, because if there is some kind of resonance, then this double bond will participate in resonance, and that's why double bond character will decrease, and finally CO bond easily you can break. Okay, so you have to find the system which participates into resonance. So this one, because this kind of resonance, and this one also. So here in this system the conjugation occurs. This is A, this is B, and this is C. Here in this system the conjugation occurs in this ring, but here conjugation occurs outside the ring. But the conjugation inside the ring is that much more effective than the outside. That's why this resonance is much more effective than this one. So that's why this resonance will be much more preferable than this, and that's why we will get we can say that this carbonyl will can be stressed, or this carbonyl group is not that much strong than this, and here in this case no, that kind of resonance is possible. Okay, so that is why this, that is B, is the B carbonyl group of B is strongest, then coming to option C and A. So you have to just know that the system which did not participate or lessly participate in resonance, that will have the higher CO frequency, carbonyl stretching frequency. Okay, and next coming to question number 40, that says that the order of the relative rate of the cyclization of bromose carboxyl, okay, to form lactone. Okay, so you just need to know here one thing, that in case of thermodynamic controlled reaction, there are two types of reaction: thermodynamic controlled reaction and kinetically controlled reaction. So in case of thermodynamically controlled reaction, 5-member ring is much more stable than 6-member ring. You just need to know this one. Okay, and for kinetic I will not elaborate this because it will not be considered right here, and that's why here the reaction or the system, that is generation of lactones, is a thermodynamically controlled reaction, and that's why the system ABC, there are three systems right here, and the system which will form the 5-member ring will be much more stable. Okay, and that will form the most stable lactones. Okay, so you can easily understand, I'm just drawing the correct one. So B will have the highest stable, B will form the highest stable lactone. Why? Because this kind of resonance you may easily consider, and what we get, we will get the product like this: 1-member, 2-member, 3-member, 4-member, and 5-member, and this one. Okay, so this lactone is much more stable. Then coming to option 6-member lactone, then 4-member lactone. So option B, then C, then A, this will be correct. Okay, so this is all about the 10 questions from part B, and in the subsequent videos you will get another 10 questions. Okay, and also you can join my Facebook group. You can get the link in the description below, and over there you can ask your queries. Okay, and if you have given the NET December 2018, then let me know in the comment box that how was your exam. Okay, how was your experience, if you have given the first time or the second or third time or fourth time or much more. Okay, so just let me know all those in the comment box, and as usual keep watching, keep following, and thanks for watching.